Okay, we are recording. Fine. Um, Hello all and good. Excuse me. Who is that? Okay, yeah. Fine. So, good afternoon to on a Saturday evening, Saturday afternoon. So I am Raj, and I generally I'm a PhD student in IISc in the CSA department. And I'm a PMRFTA, so we are a bit different from your normal
Sir,
TAs.
can you please silent your mobile phone?
It's not mobile phone actually, sadly. It's the
Yeah.
uh, just a second. Mm, Outside. Can you hear me still? I can't hear you. Okay, sorry. Mm, yeah. Well, let's see. Hopefully, I think now people should not be joining anymore. How many we are? 101. Yeah. Oh, okay. ठीक है. Okay, let's continue. Yeah, so I'm a PhD student in IISc from CSA department, and I'm a PMRFTA. So we are not your regular TAs. We generally will handle some sort of live interaction session, doubt clearing session, and some problems from general doubts as such, right? Um, all right. So today's agenda is basically trying to solve some probability and linear algebra problems. um, all right, and see, okay, we'll just go to some administrative things here. So, whatever I scribble here on this particular this one, it will be recorded, it will be saved, and we also are recording the session. So, just focus on problem solving than note taking as such. My thing will always be on Saturdays from 4 to 5 p.m. And we'll generally do some problem solving, programming. Also, it is in pipeline. We might start doing some programming and doubt clearing session. And see, I cannot see the chat from this tab, so just feel free to interrupt me and ask out. Okay, you can just unmute yourself and state your name so that I know exactly who is asking the doubt, and then we can solve your doubt at that time. And in case somebody gets dropped because of exceeding time, you can just join again. I've been told that works. All right. So do we have any doubts right now as such before we begin? So you guys had a session already, right? 3 to 4 p.m. if I'm not wrong.
Yes, sir.
Okay. Okay. Good. ठीक है. Sorry. Who is that? Sai Supriya, can you mute yourself? Yeah. Thank you. Good enough. Okay, so we'll do some two problems today on probability and two problems on linear algebra. Can you see the screen? And we'll start from this problem today. Um, so the question that we have is that there are n bins, in which the kth bin contains k minus 1 blue balls and n minus k red balls, and you're going to pick a bin at random and then remove two balls at random without replacement. This is important. Find the probability that the second ball is red given the first is red. Okay. So any idea how we should proceed in this problem? Anyone? No idea.
So, can you repeat the statement, please?
Sorry.
Can you repeat the question, please?
Ha. So it's on the screen. So ideally, there are n bins. That is basically you have n boxes sort of, and the kth box, that is any kth box, will contain k minus 1 blue balls and n minus k red balls. Okay. So let's say I have.
Please repeat the font size. Let me start taking.
Oh dear. 1 second. Is this better?
No.
me just type it out if I'm not.
Are you using mobile or something? We are
No.
able to see it. No, we are using. I'm able to see it in a photo.
Sorry.
Somebody is using 14-inch of screen, then it is coming proper.
Okay. So okay, I'll just type it out and let's see if this works. Is this clearer at least?
Yes, much better.
Okay. And means of which kth contains so you pick a bin at random and remove. So you need to find the probability that one, the second ball is red, and two, second ball is red given that the first is red. Yeah, is this clearer? Okay.
Yes.
Awesome. ठीक है. So you guys got the question clear? So ideally you have, let's say, multiple bins, 1, 2 and 3 and so on up till nth bin, right? And this is 1, and any kth bin if I pick, let's say this is the kth bin, so this guy has two kinds of balls, and one is it has k minus 1 blue balls, right, and n minus k red balls. Okay. So what this means basically, so when I pick 1, it means it has 0 red blue balls, and n minus 1, so 0 blue and n minus 1 red. And if I pick this nth bin, I have n minus 1 blue and 0 red, right? So total, that means each bin has total of n minus 1 balls. It is just that the distribution of these blue and red changes, right? And it changes very uniformly, like it changes very nicely. It goes like you keep on adding one blue, keep on removing one red, so that the total number of balls in every bin is constant, which is n minus 1. Okay, so what they're asking is basically that can so you want to know what's the probability of picking the second ball is red. And how do you do this picking is, first you pick a bin. Okay, this is the first step that you do. In that bin you then take two balls, and that too without replacement. Okay, and so then the question is, if you pick in this way, what is the probability the second ball is red? This is one question. Second question is, what is the probability the second ball is red given the first ball is red? Okay, I hope you can understand what is the exact difference between these two. Otherwise we will anyway discuss the problem in detail. So any doubt in the question as such?
Okay.
No? Okay, fine. So we'll move ahead and see, again I cannot see the chat, so please, if you have any doubt, just unmute yourself and ask ahead. Okay, all right. So first things first, the way I feel we should approach these kind of problems is to first understand what sort of events are possible and giving them some meaningful symbols as such. So let's say I will call bk as the event of picking the kth bin. Okay, let's say R1 is picking red ball first, and R2 picking red ball second. Okay, so these are your events. Can anybody tell me how or what does it mean to find the probability of second ball is red. What does it mean in these symbols? Yeah.
Second ball is red means the first ball may be red and first ball may be blue.
Correct.
But second ball should be red only.
Correct. Yeah. Yes, that is true. So when you say second ball is red, the first ball can be anything. So what we basically want, can you please mute yourself? Who is unmuted?
So,
Yeah,
okay, so
somebody.
I'm getting the probability as a function of n.
Uh, I can understand that. We'll discuss that.
Okay.
So it won't be a function of n. You can actually find out the probability in normal numbers. Yeah. Okay, we'll come to that. So what we want is basically in the first part of the question, we want probability of R2. Yeah. What is probability that the second ball is red? Now, if you want to do this, what you can do is, do any of you know what is total probability formula?
Event divided by total space.
Correct. So let's say, I'm not sure if this was covered in your this one, but let me just do it for now. Okay. So let's say I have two events, C1 and C2, and this is your whole probability space. Okay. And let's say I have another event, which is, let's say, D. Okay. So if I want the probability of D, one way of looking at the probability is I can look at the conditional probability of D given C1 into probability of C1 and then add it up like this. D given C2, probability of C2. This is under the condition that C1 intersection C2 is phi, C1 union C2 is basically your whole sample space. So what we're saying, right? We're saying that if I can divide the whole sample space into two such events, right? Such that C1, C2, they have nothing in common, and if you take the union, I'll get back the whole sample space. In such a case, I can find this probability of D, this event D, in this form also. You can find in many different ways. This is one way of doing it. Okay. So let me just extend this idea a bit. So let's say, so in case, let's say I can break this sample space into even more events. Let's say I can do it in, let's say, Ci, such that I goes from 1 to some n. Then I can write probability of D as a summation I equal to 1 to n, probability of D given Ci into probability of Ci. Okay. Where if you intersect any of them, you should get null set, and if you union all of them, you should get the sample space. These are the conditions under which this holds. Okay. So here, one way to solve this problem is this, that I can basically break this down, this R2 event, into all your BK events, right? So what I will do is, I will say this is basically equal to summation I equal to 1 to n. I have n bins, right? So I can write R2 given, let me just use k only, so that's simpler. So BK into probability of BK. Okay. Why? Because see, picking one bin and picking second bin, these two are not same, right? There's nothing to nothing common among them. And if I pick any bin, it's basically your sample space, right? So this particular logic holds because any Bi and Bj, if I intersect, I get them phi, and
I think
union.
page is not
Sir,
page
Sorry,
is not refreshing. We can't see what you are typing, right? Yeah.
sorry, what happened? Yeah. Are you able to see what I'm writing?
It's clear to me.
It's clear. Okay. Yeah. Anyone had a doubt? Okay, fine, we'll continue. Okay, so this is the idea basically, that I can break this down, I can break this event R2 down into like this particular way. Okay, so next, so if so now the question is, what is probability of BK? Any idea what probability of BK is? Do we know from the question anything about probability of BK?
It's randomly chosen, right? It should be 1 by n.
1 by n, correct. So in case, see, you've been told that you pick a bin at random. Okay, so when you pick a bin at random, if they haven't given you any kind of probability distribution, you can assume that it is uniform distribution. So if it is uniform distribution and we have n bins, so picking any one bin from n bins is 1 by n. Simple. Okay, now what is probability of R2 given BK? How will you try to understand this? And let me just again give you the facts. BK, bin K has basically I think K minus 1 red, right? Let me just confirm that. K minus 1 blue. Okay, sorry. Okay. K minus 1 blue. Yeah. K minus 1 blue and n minus k red. Okay, so what is the probability that given that you have chosen a bin BK, what's the probability that the second ball, when you choose without replacement, this is very important, without replacement, what's the probability? Okay, anyone want to take a crack at this? How would you go about this?
Without replacement is first ball, you choose first ball. What is the probability of being choosing the first ball is? So it is equal. So
It will be sum of two events.
It can be red or it can be blue as well. So somewhere summation, it looks like somewhere summation we have to do. But suppose that I am taking blue only. The first ball is blue. Then total number of blue is k minus 1. So k minus 1 divided by k minus 1 upon n.
K minus 1 upon n. Okay.
Upon n.
Sorry. K minus 1 upon n.
N.
Yeah.
And for the second ball, again I have to take the. Red I have to take then n minus 1 upon n minus 1.
N minus 1 upon n minus 1, is it?
N minus k upon n minus 1.
N minus 1.
Yeah. Again, for the blue, because first one I taken blue, so again I have to take a red one. For red one, n minus k upon n plus multiplied by n minus k upon n minus k upon n minus k or upon n minus 1. Yes.
Okay.
This is what I do.
Okay. Does anyone have issues with this? Shall I continue with this?
Yeah. So first one.
Total number of balls
should be k minus.
1 second.
Go ahead.
Who is? Yeah. Continue. Yeah. Somebody one of them continue, please. Yeah.
Yeah. So I think the total number of balls is n minus 1 in every bin.
Right.
So the first one should be k minus 1 by n minus 1 into n minus k by n minus 2.
Right.
And the next one would be similarly, denominator will change, n minus 1 and n minus 2. And the numerator should be, the second one will be n minus k minus 1.
Right.
Yeah, that's right.
Yeah.
Because I thought, n ball is the
Yeah. Okay. So this is basically choosing blue ball first. Okay. And this is choosing red ball first. Okay. So these are two conditions, because I can go in either of these two. So I have a plus sign here. So when you have either conditions, when you have like I can do one thing in multiple different ways, I have to go against all of those ways. So in that way I do your addition here, and then I have multiplication because I can do this in I have to do this in steps. So first step is basically choosing blue ball, and then choosing the next the R2 to be the second ball to be red. Similarly here, and because why it's n minus 2, because the number of balls is reduced and we're doing without replacement, which is the key here. So this becomes n minus 2 because we're doing without replacement, and the number of red balls are not changed in this case, so it's n minus k. Here n minus k by n minus 1 because number of red is unchanged or whatever, and then you have n minus 2 because one ball is reduced overall and one red ball has been removed, so the number of red balls is now n minus k minus 1. Simple. Okay, so this is fine. Now okay, so what will this come to?
Denominator will be n minus 1 multiplied by n minus 2.
Mm-hmm.
And then for this one,
something like this you will get, and you will say okay, n minus k also I can take common, by the way, and have k minus 1 and n minus k minus 1. So I will add them. This becomes n minus 2, right? Just let me know if there's some issue here. So finally I get this
n minus k. How did you take in column?
So I can take from here, no?
Okay.
These are multiplications. Yeah. So I can take these two, and I just need to add this. So yeah, okay. This is fine.
Yeah.
Good. Fine. So this is basically just we done a bit of it. So we are now going to your actual problem, which is basically probability of R2. We have all our parts done here. So I have probability of R2 given Bk into probability of Bk. This we know is 1 by n. I can take it out. Sigma k equal to 1 to n, and this what we did. N minus k by n minus 1. So n minus k by n minus 1. Okay, so I can take 1 by n minus common. This I can take it out, right? Sigma k equal to 1 n of n minus k. Who wants to take a crack at this? How do you do this?
So it is n into n plus 1 by 2.
Okay, that is what? That is the
whole for k is varying from 1 to n. So that there will be 2 factors, and n will be common automatically. But summation of k will be like n into n plus 1 by 2.
N will be common. So can you take a...
No, not common, but it will be another... it can go in the 2 part. n into n it will be. The first part, if you take it out, then it will be n square.
Correct.
And then n into n plus 1 by 2 for the kth part.
Perfect. So, and you can go ahead and solve this. You will get, can take n common here. So 2n minus n is n minus 1. You will get, sorry. Yeah, so this you will get as half. Fine?
Yeah.
Makes sense?
Yes.
Good. Okay. What is the next question we have? Next question we have is, next part of the question is basically, what is the probability that, it is red given that the first one is red. Okay. The second part is this. Second ball is red given that the first one is red. So any ideas how we should proceed?
So there you we have already solved, I believe. But we have to take it from those data we have to extract it from there. Because here, first is already given. So for the red one, I think we should go to the problem.
Sorry?
There we have already solved, I believe.
We have shown what actually?
We have already solved.
No. So yeah, there was one sub case of it. That is true. That I'm not disagreeing. How do you go about solving this question? If you have to solve this methodically, how would you go about solving this? So okay, so leave all that. What does the problem tell you in terms of symbols? What probability do you want? P of what do I write? Anyone? So the question is, what is the probability that the second ball is red given the first ball is red? So how do you represent this probabilistically? What is the symbols? What do you mean by
R2 given R1, right?
R2 given R1. Simple. Nice. Now, okay. So conditional probability, if you wanted to use, what is the in a way definition of conditional probability?
Probability of R divided by probability of R1. But on the top, you will have like a probability of R1 union, R1 intersection R2.
Correct. R1 intersection R2. So R1 intersection R2, you can write it as R1 R2 also. I mean, just I'm letting you know. So this is also fine. Okay. So now the thing is, we have this, we need this, right? So I can just solve the same thing in this format. K equal to 1 to n, probability of R1 R2 given bk into probability of bk. Now probability of bk, we know it's 1 by n, right? Now this is where that part comes into play, because what I need the first one to be red, second one also to be red, right? So that we already saw here, right? This is exactly that particular equation, right? So there's no way to, yeah, n minus k by n minus 1. Just let me know if this is n minus k minus 1 by n minus 2. Yeah, this makes sense? Any doubts?
Yeah.
No? Okay, fine. So now chalo, theek. So now what you have is you have a very scale looking expression. You can basically sort of try to yeah, anyone want to try it out? Let me know what the answer will come. And by the way, how would you go about doing this also? You can think about it, because what will happen is now you get, so I'll go a bit faster here because this is a bit of high school algebra. So this is
n minus k whole square.
N square, I mean, yeah, we can do that also. N square minus nk minus n minus again kn plus k. This you will get n cubed. You will take n common here. You will get again sigma k, that is n minus n plus 1 by 2. And you'll get n square here. Same thing. What is sigma k equal to 1 to n k squared? Sum of first square terms. Any idea?
Symmetric
Into
yes.
and n plus 1 plus 1 by 6.
Yeah, 2n plus 1 by 6. So I'll say just, put all this here. You should get, if I'm not wrong, 1 by 3. Yeah. So I'm leaving this out in case you have an issue by the end of this one, or we can ask again.
Can we go to the previous slide?
Yeah. 1 second.
Here we have written like probability of R1 upon R1 R2, that is the intersection of R1 and R2.
Yeah.
Where the from decay is coming, the summation area. Yeah.
This one? This is the same thing. The total probability formula, no? So what I'm doing here is I'm treating this R1 R2 as one event, right? So same thing. So probability of C, I can write it as I equal to 1 to n. Probability of C given di into probability of di, where all the di's should be a partition. So that is the same thing here, which is what we used here, no? Where is that? Yeah, here. Yeah. Oh no, 1 second. So yeah, so this will not be 1 by 3. This will be, I think, something 2 by 3. So final answer is what you get. This R2 given R1 is 1 by 3. This should be, I think, 2 by 3 or something. You can just verify this. Yeah. 1 by 6 is it? Yeah. This you should get 1 by 6. Just let me know if you're not getting this 1 by 6. We can try to solve this end to end. Okay. Any doubts here on the approach, on what this is, etc.? Anything? Okay. I am assuming no questions. Will move forward. All right. So let me know if this is also unclear. Is this big enough now? This question, 7th question, number 7.
Yeah.
Okay. All right. Okay, these are straightforward questions, sort of. So we'll just go a bit quickly here. So what is the question they're asking, or it's saying, right? So let's say A is a matrix of real numbers. Fine. A transpose has an eigenvector x with eigenvalue b. So what does eigenvector, eigenvalue mean? So tell me what the statement means in terms of equations.
A transpose x equal to bx.
A transpose x equal to bx, right? Good enough. Now the question is, what is it? So we have an eigenvector y of A transpose A, which has eigenvalue b equal to what, right? So let's say there is some eigenvector y which has the same eigenvalue b. So what is this eigenvector? What does y represent for this A transpose A? That's the question we are asking. So all right, so any thoughts how we should proceed here? Any ideas? No ideas. So first thing is, see, what you want is, you want A transpose A, not A transpose anymore. So
Oh no, okay.
sorry, please try to keep it on mute. Yeah, okay, fine. So yeah, so we have A transpose X, but you want A transpose A. So one might think that I can try to try to transpose this somehow, make sure, and then get some value out of it, but that won't work.
Is B?
Sorry?
Is it B?
No. So see, the question
Option.
is, what is the
Option.
eigen? Oh, yeah.
Option.
Option is B. Yes. So anyway, so how do you get that?
So I pre-multiply it with A transpose.
Yeah. So you get this. Okay.
And since I have to get A transpose A times Y, so in the left hand side I take in the left hand side I take A transpose and replace it by Y on the both sides. So that will serve my equation.
Right. Excuse me. Who is Sheikh Mohammed? Can you please? All right. Yeah, sorry for that. Anyway, so yeah, so the idea is that now I can if you see what the idea of eigenvectors is, that you can basically write like this: Ax equal to lambda. Let me not use the same symbols. Yeah. So something like b z equal to lambda z, let's say. So z is the eigenvector of b. So in this way, now this basically is the eigenvector y, will be a vector y, and if you see, it's multiplying this y with this A transpose A and has the eigenvalue b. So which is what we wanted. So this is A transpose x, right? So simple and straightforward. All right. Cool. We'll do the next one. Let me just yeah, okay, let's do this question again. It should be a simple straightforward application of what eigenvectors, the definition of eigenvectors is. So what they're saying, okay, so let's say we have a u vector which is a n cross 1 vector such that u transpose u equals to 1. And I is an identity matrix, which we know. Good. N cross A matrix A is given by I minus K U transpose. So that is A is basically I minus K U transpose, where K is a real constant. U itself is an eigenvector of A with eigenvalue -1. So if I apply the definition of eigenvectors, what this means is it's just saying AU equals to minus U. Yeah. So what is the value of K? Now we just have two equations. So basically just put the equations together. So AU, to multiply U here. So I get I minus K U transpose into U, right? This is this. This becomes U minus K U transpose U. U transpose U is equal to 1, right? So I can write U minus KU. Now this has to be equal to minus U from here. So yeah, so KU transposing will get 2U, K is equal to 2. Yeah, that's it. Simple and straightforward problem. Any doubts here? So this is from eigenvector definition. All right. Okay. We'll move to the next question. Next is a probability question. Can you not see this also?
So I'd like to ask, where are you picking these questions from? I mean, are these just random questions that you brought for this exercise, or are these part of an assignment that we have?
Assignment.
So yeah, so one second. So these two questions, the eigenvector ones, I got it from a previous assignment something. This is, if I'm not wrong, this is your part of your practice assignment, no? The first question.
Yes.
Okay, sir.
So if I'm not wrong, it's week 1 practice assignment, and even
So in the practice assignment first one,
yeah,
there is a question, second last question also, that is no problematic. If you can take a look on that.
So practice assignment, 1 second.
Yeah. Second last question.
Second last question. This one, medical company.
No, I have to open that actually.
Okay, so we'll do one thing. Let me. We have 120 minutes. Okay, we'll do one thing. Let me just finish the last problem, and then we'll take it up. Yeah, we'll do the last one a bit quick. Yeah, that's fine.
Yeah.
Okay. So good enough. We'll try to finish this. So what are we saying? We're saying here in this question that x and y are uniformly distributed random variables over the interval 0, 4 and 0, 6 respectively. Anyone want to tell me what a uniformly distributed random variable is? What does it?
Chances of appearance is equal.
Yeah, that is true. Any idea on how to write the PDF of x? If I want to write the PDF of x?
If the range is from A to B, the distribution function is 1 by B minus A.
1 by B minus A, right? So here in this case, it's 1 by 4. F of x, f of y is 1 by 6, right? Because A is 0, B is 4, A is 0, B is 6, right? Now, what do you want? Do you want to compute the probability of this particular thing? So probability max of x, y greater than 3. Okay, and one important thing I said is that these are independent events. All right. So see, No, okay, so 1 by 4 in the range of if x is between 0 and 4, remaining it will be 0 else, and same thing here, 0 less than y less than 6, 0 else, right? This is the proper distribution, I mean the way to write this PDFs of these two variables. Now, if that's the case, uh, when will the maximum of x and y be greater than 3? I can write this in 3 ways, okay? That if x is greater than 3 and y is less than 3, that's one possibility. Or x is less than 3 and y is greater than 3, and x is greater than 3 and y also is greater than 3, right? Is this right?
Yes.
Any doubts here? Fine. Now what you've been told, we are told that these two are independent events, right? So this is a joint probability. So for joint probability for independent events, I can just write it as their probability, the product of their own individual probabilities, right? So this I can write it as probability of x greater than 3 into probability of y less than 3. Similarly here, sorry, y greater than 3, probability of x greater than 3 into probability of y greater than 3, right? Okay, now any idea how do you want to proceed? So if I'm not, so what, so for now to solve the next part of the thing, you need to know your CDF functions for these, okay? I mean your cumulative distribution functions. So that you can write it as like this, right? If I'm not wrong, it's x minus a by b minus a. Yeah, so it'll be x by 4. This is when x is between 4 and 0 else. Just keep an eye on this, let me know if there is some issue here. Y by 6, 0 less than, sorry, y less than 6, 0 else. 0 if y is less than 0, 1 if y is greater than 6. When x is less than 0, 1 when x is greater than 4, right? CDF functions should start from 0 and 1, anyway, end at 1, right? Okay, so now if I want to do probability of x less than 3, what will this be? Any idea?
Uh, 3 by 4.
Sorry, 3 by 4, right? Because what does it mean to have what is CDF functions, right? They're saying you if something is less than that, so this is basically what it means is this is the probability that x is less than or equal to small x. This probability is what is being captured by the CDF functions, right? And don't worry too much about the less than or equal to wala part in these cases in your continuous variables, okay? So so this becomes equal to 3 by 4. Now let's see if I want to know what is probability of x greater than 3. How would this be?
Is the answer 5 by 8?
1 by 4.
Somebody who said yeah, the answer is 5 by 8. Yeah. Anyway, so yeah, is it 1 by 4? Why? Because you can just write as 1 minus probability of x less than or equal to 3. And I said just now that you can ignore this one for now. Yeah, so you get 1 by 4. So okay, so now the answer, so you can just substitute all the stuff here. This becomes equal to x greater than 3 is 1 by 4 into y less than 3 becomes 1 by 2 plus x less than 3 is 3 by 4, y greater than 3 is again 1 by 2 plus x greater than 3 1 by 4 into 1 by 2. Sorry for the horrible handwriting. So you'll get here this 1 by 8, this 1 by 8, this 3 by 8. So you'll get totally 5 by 8. Okay. The person who confirmed, who told the answer, you have any different approach you want to let us know?
Yeah. So what I did was I plotted x and y on orthogonal as the perpendicular axis. And I took a rectangle on the x-axis 0 to 4, on the y-axis 0 to 6. And then I drew a vertical line and a horizontal line at x equal to 3 and y equal to 3. So I have the rectangle divided into 4 areas. Now, since there are 3 situations, x greater than 3, y less than 3, x greater than 3, y greater than 3, and x greater than 3, y greater than 3. So accordingly, I find the area of those rectangles and divide it by the total rectangle area.
Total rectangle area. Right. This, yeah, that's correct. So this, let's say this is 3. This is 3. So you said as such that if this is more than this is one area that you want. This is another area. That's it, right?
Yeah. So I extend the vertical line till it touches x equal to 6 also.
X equal to 6.
Y equal to 6. Yeah, that line. So there are four areas. Yes.
Yeah, correct. So you'll have these 3 areas that you want to capture, right?
Yes.
Makes sense. So actually, so this is basically 4 into 3, that is 12. Sorry, let me just. So I'll do one thing. I'll just divide into 2 areas. You can just do that also. It's fine. Just for simplicity.
4 minus 9.
So therefore, so the area of this guy, the upper res one, will be 4 into 3. So it's 12 plus this guy. This guy is basically, the width is 1 and the height is 3. So it's 3. So it's 15, and total area is 4 is 24. So 15 by 24. So this will be 3 5 3 8. Perfect. Yeah. Okay, that's good enough. So I had this question. I mean, brainstorm question. We can do it afterwards. Let me just do. The person who wanted to do the last but one question. Do you have a clarity?
On the practice session, was I have to.
Practice of week 1. Is this the question that you're asking? Oh, sorry. Oh, you can't see. Sorry. Yeah. 1 second. So is it this what do you call that, the medical thing? No,
not medical thing.
Okay.
Just give me a second.
Okay, so we can do one thing, just keep in mind, we can do it next week also. I think there's not this one, or if possible, we can do it in the next
experiment. It was like that. In an experiment from previous question, what is the probability of picking red ball? Red ball for the first time on the 4th attempt.
Okay, that question. I'm sure. I think I read it somewhere. Just give me 1 second.
I mail it as well. There's a ball. I'm typing this my chat.
Okay. Is this one it? Let me just type it here. This one?
Yeah.
And then again, in the experiment previous question. So that's okay, fine. So we have 2 parts here. So first part is this, second part is this. Okay. So we'll do one thing. The first part we'll do no problem. Okay. So first things first. Okay, what is the question that we have, right? So let's say, given a bag, can all see the question easily visible?
Yes.
Okay. Fine. So given a bag contains 6 red balls, 4 blue balls, 7 green balls, what is the probability that in 5 trials at least 3 red balls are drawn from the bag? So here in this case they have said nothing about what do you call the replacement or without replacement, whatever. Just take it as with replacement. Okay, replacement is done. So in case it is not, you can just they will mention ideally. If they have not mentioned, in all cases just take it as with replacement. All right. So if this is the case, so I have 6 red, 4 blue, 7 green. In 5 trials, at least 3 red balls are taken. So I'm doing 5 trials. I pick one ball and I see its color. Okay. And in the 5, I do this 5 times. And my question is whether I get at least 3. What's the probability that I will get at least 3 from these 5 trials? Okay, so I'll give you, see, we are trying to ascertain only with respect to red, right? So what I will do is I will think of 2 events sort of. I'll say, okay, R is picking red and R bar is not picking red, because I don't care what the other color is, right? Hai. So now I have basically broken this down into a simpler experiment. I can just say, is it red? Not red. Okay. And then I have a thing that, okay, in 5 trials I need to check what is the probability of getting at least three red balls. So any idea what sort of a probability distribution this corresponds to?
Yeah, it should be binomial distribution, right? Because there are only 2 possible cases.
Correct. So yeah, it's a binomial distribution, right? So so out of so your n is 5, where you're asking you're doing n times, it's 5 times 5 trials, right? And the question that you're asking is, what is the probability that x is at least 3, px greater than or equal to 3. Now we know what is px equal to k. Any what's the formula for binomial distribution in this case? X equal to k.
NCK
NCK
P bar K 1 minus P power n minus K. So
right. And what is P? P is the probability of picking red. Now what is the probability of picking red?
red.
Hello? Yeah. So the probability of picking red is?
6 by 17.
6 by 17. That's it. So just
17.
Yeah. So just put that here. Now the thing is, they're asking, okay, what is probability of x greater than or equal to 3? So how will you do that? You will say, okay, x greater than or equal to 3 is basically summation of k equal to 3 to 5 p of x equal to k. So just substitute, you will get these values. I'm not sure what the answer is, but yeah, that's how you solve this. Okay, this is the first thing. Second thing is this question. So in the experiment from previous question, what's the probability of picking a red ball for the first time on the 4th attempt? Okay, this also is a probability distribution. Any idea what this probability distribution is? First
I
time.
think is it geometric distribution?
Yeah, it's geometric distribution. Yeah. Okay. Yeah. So again, so without going there also, what is the question you're saying? First time. So you should pick red for the first time on the 4th attempt. So the first 3 attempts should be not red, right? So first 3 attempts should be not red. Event R bar should be should happen, and the 4th attempt R should happen.
Yeah, it can be done with the geometric, but how you are distinguishing in this geometric and the binomial distribution? Because from the question, both looks like similar, and we are here if we are doing geometric, and there we are binomial.
Okay. Okay. So I'll just finish this. Just give me 1 second, and we'll discuss why is that. Anyway, so here the probability of the whatever the question that you're asking is basically probability of R bar times 3 into probability of R. So this will be just be 11 by 17 cubed, 6 by 17. We'll get something here. Fine. So yeah. So the question is, what is the difference
from the
between
question? How you are distinguishing that this is binomial and this is geometric?
Yeah, binomial and geometric. So see, in the question was that in at least 3 times, right? Here and here it is first red on 4th attempt, 4th trial, whatever you want to call it. Yeah. So here, in some sense, exactly, what should happen on the first 3, right? On the first 3 trials, you need them to be not red. At least 3 times out of 5 times, whatever. So here there is no constraint on, okay, by the first time out of this 5 should be some, non-red or red or anything. It's not saying that. It's saying I will take 5 times. Any of these 3 should be red. At least, sorry, yeah, at least 3 in the sense 3 or more.
Any of them, any of
them.
position can be filled with a red ball.
Correct. So basically this is valid, or I can put this is valid, or I can put this is valid. I can put 4 also, because we're saying at least 3, like that. In this, let's say if I were to go whatever, here it has to be not red, it has to be not red, it has to be not red. Now it can be red, and now after this I don't care. Here it can be any ball that you pick. I can go on to infinity, I don't care. The question here is, first time that I see red should be on the 4th trial. That event I'm interested in, and what's the probability of that event. Is that clear? Good. All right. Okay, we have some 3-4 minutes here. People who are interested can stay back and let me know if you have to solve this problem. You are now studying machine learning. If you want to predict tomorrow's weather, how would you go about it? It's an open-ended question. Nothing here. But yeah, I just want to know what your ideas are. How would you go about predicting tomorrow's weather?
Start with today's weather as a base.
Okay. So in some sense, if I'm not wrong, you're saying we can use, in the input, I can use today's weather.
We can look at the last year during the same time, the weather last year, and how does the season go about?
Last year's weather during this time. Okay. What else would you use to make sure? I mean, to get this. If you have to now, sort of implement this in code in a computer, how would you go about now? What else would you need, or any ideas?
You can use the features like humidity.
You can apply
one by one. Yeah. Tell me who's
You can use the features like humidity and environment.
Humidity. Yeah. And what is it? Humidity
and the features which causes reading.
Like
that.
From the previous data.
Right? Yeah, we've covered that.
Dust and humidity that triggers reading.
Okay. What else?
Maybe latitude and longitude of that particular location.
Correct. So no, so this is open-ended. I have not said which location, so I can just pick one, or I can just do for all the locations in the world. So I can latitude and longitude of the location. Makes sense. Yeah. Next, what else? What else?
So you can convert this problem into a time series. So time series of a variable where there is rain or no rain. And then we can keep track of the last 1 year and see the components of the time series, which include, let's say, trend, seasonality, and stationarity. All those components we can see and try to figure out a correlation pattern bit through this time series by sweeping a time window and see whether there is a correlation and what sort of correlation window we have. Depending on that, we can predict the correlation. Maybe if we know the correlation window, let's say 2 weeks or 3 weeks, if that is the correlation window, then my baseline for tomorrow's weather will be minus that time, which is the correlation window, and that will give me the prediction for tomorrow's weather.
Good. Yeah. Modeling it as a time series. Good idea. Yeah. Next. Anything else? So I'm highlighting here. Just think about this also. For example, let's say tomorrow. If you want to put this in code, how would you go about it? Is rain, no rain the only thing that about a weather? So we are, in India at least, we have so many different weathers going on, right? So you have.
Yeah. So there are so many attributes of it. You have to predict, if it is rainy, sunny, windy. Apart from that, you have to also predict about the humidity. So these are the different parameters you have to produce by help of whatever the algorithm you are taking.
Right.
But weather means these many components actually.
Correct.
And after combining all these, you can have rain or no rain.
I think only two parameters are essentially required. One is temperature and one is humidity. By that, we can approximately get to any kind of weather. Because these two parameters, because if it is cold, then it will be less temperature, and rainy would be predicted by humidity.
So basically humidity and temperature. Yeah. So what you're saying is I will have some ML model which takes in all data, predicts only two variables for me, and using this I can make an inference on the type. Correct? Because so I will basically characterize all my different weathers of raining or cold or whatever, etc., as parameterized by these two. Correct? Cool. Yeah, so this is one thing. Humidity, by the way, doesn't it has a percentage range, right? If I'm not wrong.
Yes.
So it's a percentage range. So it will be from 0 to 1. You have to predict something from 0 to 1. Any idea what this 0 to 1? What sort of problem does this correspond to? Regression or classification?
Regression.
Regression, right? What is temperature? Regression or
Also
classification?
regression.
Again regression. Good enough.
Yeah.
Right. So this is this. If I were to build an ML model which gives me the types directly, right? Now what you're saying is we are doing okay. I will, parameterize all my different weather types on these two parameters, right? Humidity and temperature. I'll just predict these two parameters. In case I didn't want to do this, I said okay, I will directly try to get these types. What would that be called? Regression or classification?
Classification.
Right? Because you're saying it's whether one versus the other, right? You're saying will it rain, will it be cold, will it be humid, will it be snowing, etc. So it's one of each of these. You'll have a classification. Now there are many ways to deal with time series data. So there's something called as recurrent networks which deal with time series data. So generally ML the ones that you study here is for tabular kind of data, right? So where you have like a table sort of a thing, you have multiple attributes, you'll put all of this into the machine learning algorithm, you try to predict this sort of thing. Whereas here the idea is that you have a series of stuff and you want to predict from this series something. Yeah. Anyway, that's just a idea I wanted to give. Anyway.